All right, welcome. Sorry about earlier this week. I was totally sick. I think I'm better today, hopefully, but I guess we'll see. I do want to check in because I've got my kind of my old setup. I tried to set it up and testing. Is my microphone working? Or is it not using this one? I don't know. I can't tell. So let me know if it's not working. But otherwise, I mean, the light is on, so I don't know. But I didn't do a test run this morning, so it's awesome. And I've got my fancy webcam, so now you can actually see me. So you can see me, you can hear me. All right, good. I guess that's all I need. Okay, so I posted a video. It was from last term, but of course, I mean, it's the same course. So if my voice goes again, I'll have to do that again, but I'll try not to because it gets confusing. But the video from last day, if you haven't watched it already, that's fine. You've got time because we're just starting categorical data today, but just make sure that you watch that to wrap up 5-number summaries and box plots, which wraps up numerical data. So let me see here. If you haven't watched the video, that concludes kind of the introduction to numerical data, that's okay. Just make sure that you do it over the weekend. I know you probably have a long list of things to do over the weekend. I always head into the weekend so hopeful that I'm going to get stuff done, and then I get only a tiny bit done. That's okay. That's normal. So if you haven't watched the video, that concludes our introduction to numerical data. It's from September 23rd. And I put it in our on our playlist on YouTube. And I also posted the notes, and they're just called September 23rd, 2021. Okay. So if you haven't watched the video, then make sure you watch it over the weekend. Make sure you watch it. I guess technically just before quiz 1, but which I want to talk about, but also before you try assignment 2, which I posted. Okay, I got a direct message here, but I'm gonna put that off until just because it's hard to answer direct messages in class. So if you could send me an email about that, that would be better, or if you can just text me. So make sure you watch it before completing assignment 2. Okay. So assignment number 2 is posted. Assignment number 2 is for chapter 2. Is posted and is due. When did I make it due, I wonder? I'll have to check. Assignment 2, does it tell me due on Thursday? That makes sense. I usually do a week to a week. So from the day I introduce an assignment, unless we're short on time. So if I'm trying to get you to work on stuff before a quiz, for example, then I might make it a little shorter. But then I also make the actual assignment a little bit shorter too. So is due February 2nd, which is Thursday. Can you believe it? Heading into February already. I did post a recording. I was feeling really sick, and it took me a long time to get it sorted, mostly because I was having internet issues, but also it just took me a long time. It's going through how to do stuff in R. Oh, good question. Thursday, is it it is the 3rd. So why did it say due Thursday? Oh, it is the 3rd. Thank you. So there is a video from last Friday, but it's just using R to do numerical summaries for numerical data. Oh, okay. You're so right. It is the 3rd. Good thing you guys are keeping me honest. February 3rd. Easy fix. Oh yeah, sorry. Last Friday took me forever to do the video. I was feeling really sick. And then yeah, there should be a video, but it was also having a hard time loading. Like I thought I had put up videos from the day before, but then they hadn't loaded on YouTube. They were just kind of pending. So maybe check that out and see, just make sure. But it's called numerical summaries in R, I think, something like that. All my due dates are at 11:59, and because it's not a Moodle quiz per se, it's from an outside source, and then I just bring it into Moodle, these assignments. So what I do is I put a little reminder in our calendar, and so hopefully you can see those reminders of when they're due. Sometimes I forget to update them, so just whatever the due date that pops up when you open the quiz, that's the one that's right. Okay, good. So I want to talk about quiz number 1. Quiz number 1 is going to be available next Friday. So there won't be a video for next Friday. Will be available next Friday, which is the 4th. Time flies when you're having fun. And so it's going to be a 50-minute timed quiz. So a 50-minute timed quiz. So when you start it, you'll only have one attempt, of course. It's open book, right? So use your resources, everything except each other, right? So just kind of relying on things, knowledge that you have access to, okay? And so I'm not testing you on any R. So that video from last Friday, I'm not testing you on it, but it is a bonus question. And so no R code will be tested, but there will be one. But there will be one question, one bonus question. that asks for the standard deviation, and I would encourage you to use software for that. Now, you don't have to use R. I've given you the tools to use R, so you know you could follow those instructions and you could use R to do it. But there's online calculators. You can use Excel if you prefer. There's lots of options. Okay, so no R code will be tested, but there is one bonus question that asks you to calculate the standard deviation where software might be useful, right? You don't have to, you could do it by hand, but it's going to be quite a large data set, so that wouldn't be very fun. Okay. So it is open book. It's available next Friday from 8 o'clock. And maybe I'll bump this down here, just give myself one more line here, until Sunday, February 6th, I guess. Again at 11:59, so midnight on Sunday. So you can use the class time that we have scheduled to do it, right? That's why it's a 50-minute timed quiz, is because you could sit down and you could use that time, but you don't have to, right? So you can kind of schedule it sometime in that weekend. Okay. You can't use any late passes, so you will not be able to use a late pass for the quizzes. That goes for all the quizzes. Remember, we're going to have 4 quizzes. Yeah, so because, so I got 2 questions here. How many questions will there be in the quiz? Typically around 20. Honestly, it depends on, so I haven't made it yet because I was doing, just 2 tests. So I haven't finalized the quiz. Typically around 20 questions is good for a 50-minute quiz. However, if there are some questions that take longer, of course, then I would decrease it. So it's really just time-based. It's not number of questions based. So I have a hard time answering that question, because I could make one question that would take you 50 minutes, right? And so, so I'm not going to commit to a number of questions. It's purely time-based. And what I do to decide the time is I write it. And so I sit down and I do the quiz, and then I just make sure that you have 3 times as much time. Okay, so for a 50-minute quiz, right, I would expect it to take me, well, honestly, a 50-minute quiz typically takes me about 10 minutes to write, but as long as I'm kind of in the 20-minute range, I'm usually safe. So 15 minutes for me to write. And then that should be a 50-minute quiz for you guys. Okay, I'm faster, but also I made the questions, so that's kind of cheating, right? So I make sure that I read all the questions properly and read all the options, because otherwise it's cheating. But I know the answers because I made the questions, right? So that's why I tend to triple my time. Oh yeah, so I got a question about if all the quizzes are going to be open book, and what about the final exam? So because we have this online option, all the testing will be online, and so I am not interested in trying to control your study space. And so yes, all the quizzes, all the final exams will be open book. You are expected to work alone, of course, but that said, that means you have to be really, really organized with all your materials, right? All your resources. Awesome. And then I got a direct message that says, how much of the grade will this quiz be worth? And that is, I can't quite remember. Maybe I don't have it here. Let's check. It's in the outline, obviously. Let's see here. Quizzes are 40%, so 10% each. Okay. Oops. Quizzes are worth 10% each. Okay, so kind of low pressure, right? Because there's 4 of them, but it's also going to be a large chunk of your grade once we're done. So make sure that all your quizzes count. Okay, good. I think that's what I wanted to talk about for the quizzes. So quiz number 1, and it'll just be exactly in the same format as the assignments. And so it'll be available on Moodle. And what I want you to do, that's what I was forgetting. Okay, is I want you to be able to submit your work. Okay, I'm not going to mark your work, especially for the first one, but what could happen is you do your quiz and then you have an internet connection issue, is typically the case, and then all your answers are lost. So if you have been writing out your answers and writing out your work and you have some sort of record of the quiz that you wrote, then you'll be able to upload that, and then I can check against the answers that you should have given, and then I can still give you a grade. So it's really, really just a safety net. It's not for me to check your work or anything. It's just, if you want to have that safety net, then you can upload your work. And so for the first one, I'm going to force you to upload your work. So you have to upload your work. Okay. And so you will need to scan and upload your work. Okay. And maybe I'll say your written work as a record of the answers you submitted. Okay. Because you can do the quiz at any time, it has to be within 10 minutes. Okay, for this first one, I'm really just, I want you to get comfortable with uploading your work. And so if you have to scan your work, then yeah, so if you use R or Excel or something, then you might have to take a screenshot and include that somehow, right? And so there are kind of options. Totally. So if you're working on an iPad, then of course you're one step closer. Then you can just save it as a PDF and upload that. And that's what I do, right, with my notes. So definitely if you're on a tablet, then it's, you know, you're halfway there. But for scanning, if you're working with pen and paper, which I think most people are still, then there's lots of free scanning apps for your phone. Most phones have built-in scanners. Now, I'm on an iPhone and I don't like the built-in scanner, so I like Scannable. So what I did was I just downloaded a bunch of free scanning apps. There's Cam Scanner, Scannable, there's Adobe Scan. Okay, so there's lots available. And what I did was I just downloaded all the free ones and then I tested them, right? And so you can kind of find your way to one that you like, right? And so it's important that you're able to save to a PDF, right? How do I send it to myself? How do I share this with myself? How do I upload it to Moodle? Right. And so those are all things that you're going to need to practice. And I think what I'll do is I'll post a practice Dropbox just for you to be able to practice beforehand. So this being able to scan and upload your work is not for marks, but it is really important that you're able to do it. Okay. So I'll kind of get into more detail on that closer to Friday next week. Because that's when we have our quiz. Okay, so uploading your work is really just in case something happens, right? Then I can say, okay, well, they submitted this work within 10 minutes of doing the quiz. Seems reasonable that I can take those answers and I can apply them to the quiz and still give you marks. Okay, so it's really just for you to safeguard those marks. Okay. Okay, good. The quiz will cover all the material up to and including next Thursday. Okay, so that means that the next day, potentially, you could write the quiz on that material. Of course, you would want to practice a little bit, right? And so the assignments are going to be really good practice. Okay, so the assignment questions will be good practice questions to prepare you for the quizzes. And quiz number 1 will include material up to and including Thursday. And what did we say the Thursday was? The 3rd, Thursday, February 3rd. Okay. I've posted the textbook for a reason. I do expect you to be reading along. And in the beginning here, you know, we're just kind of getting used to each other and getting used to the textbook and getting used to everything. Oh yeah, so for your written work, you have to submit it within 10 minutes of the quiz, of finishing your quiz. So once you submit your quiz, I have a timestamp, and then I'll just check to make sure that it was within 10 minutes, because there's no way to automate that. But well, I'm sure there is, but I don't know how. So I'll give you 10 minutes after you finish the quiz. So the total that you should have planned out is 60 minutes, so a full hour. You probably won't need all that time, but just in case. For next week and for tomorrow, make sure that you read chapter 3, specifically 3.1 and 3.2. For Friday and next week, read sections 3.1 and 3.2. 3.3 and 3.4 if you have time. And 3.3 and 3.4 if you have time. Okay. chapter 3 is on probability, so I'm going to start that in the video tomorrow, just introducing probability. And it can be kind of tricky to wrap your head around. And so we're not going to spend a lot of time here in probability in chapter 3, but it's good if you've kind of read the chapter, even if it doesn't make sense when you first read it. At least if you have read the chapter, right? And then I talk about it, right? Then when I talk about it, it's the second time that you've heard it. And so it'll slowly start to sink in, right? The only way to learn this stuff is to just expose yourself to it over and over and over again. And then eventually it'll start to kind of click, okay? And so, so I do want you to be reading ahead. And I know that's a lot to ask, but these, I've posted the PDF of the textbook, right? So you have the textbook, but also each of the sections are relatively short. So I find that they're easy to read and kind of easy to follow along with. Okay, good. So if you have any other kind of administrative questions, that was a lot, then let me know. Otherwise, we're just going to wrap up categorical data today. So I'm not going to review because I'm going to leave that for the video that I posted from Tuesday, where we wrap up numerical data. And then today, and I think I did introduce some categorical stuff, and I kind of gave the spoiler alert in the video, pretty sure, but let's just start fresh for categorical data. So let's see here. Summarizing categorical data. So far, we've only talked about numerical data, and often numerical data is where we're going to put all our energy into, because there's a lot that we can do, right? We can talk about the distribution, we can talk about the center, we can talk about the spread, we have measures of center and spread, and we can find outliers using the 1.5 IQR rule. And there's just a lot of stuff that we can do. Whereas categorical data, if you think about what a categorical variable is, it's going to be a variable where each observation can be put into a category. There's really not a lot that we can do there. We can count how many things are in each category, right, from a data set. And that's pretty much it. And so the key, though, is for us to be able to identify when do I have a categorical variable. Okay, and so just as a reminder, to determine if a variable or a data, well, doesn't really make sense. It is called data, but usually I call data for a data set. So that's why I'm kind of getting hung up on that. But anyways, let's stick to variables, right? So remember, if you have a spreadsheet, right? So you have an Excel spreadsheet, for example, we've all seen some version of that. Then I have observations in my rows and I have variables in my columns. So each column can be classified as either numerical or categorical. Okay, and so how do we decide if a variable is numerical or categorical? Okay. Well, there are variables where we could be convinced either way, and that's fine, right? So there are actually many variables, and we're going to see some where You could argue it either way, and I could kind of go along with it either way. There are some variables that are clearly numerical, or some variables that are clearly categorical, right? But if you're ever having a hard time deciding which one is which, then you ask yourself, okay, does it make sense? Or would I argue that it makes sense to talk about the average? Okay, and so reminder, there are many variables that can be difficult to classify as either numerical or categorical. Yeah. Kind of depending on which way you want to argue it, right? Your argument should involve, okay, does it make sense to talk about the average? Okay. If that's the case, okay, so for these variables, we ask whether it makes sense to talk about the average. Okay. If it does, then you would say, okay, because of that, I'm going to call this a numerical variable. And if it doesn't, then you would say, okay, then it's categorical. Okay. So if yes, you would argue it's numerical. And if no, then you would argue it's categorical. Okay. So depending on what your stance is, and there are times where we might disagree, right? But as long as you have a solid argument, then I can't argue with that, right? And so we might argue different things, but as long as your argument is logical, then I can't complain about that. But as long as your argument is logical, I can't argue with that, or I can't complain. Okay. And so that's going to happen a lot, where in statistics, it is as much of an art as it is a science. Okay, so there are things that are set in stone. Okay, nope, that has to be a numerical variable because it's a measurement, right? That's a telltale sign for a numerical measurement. But we're going to see somewhere where we could be swayed either way, right? And so as long as you have the know-how, right? Meaning, okay, well, does it make sense to talk about the average? Yes, right? If you tell me yes, it does, then you should tell me that it's a numerical variable, or you will treat it as a numerical variable. Okay? So it's kind of this song and dance of, okay, well, I know what the argument is, and as long as you apply it logically, then I'm happy. Okay, and so in R, there are many built-in data sets. And so one of the most common ones, or there are lots of common ones. There's the IRIS data set, which is really common. There's the MT-CARS data set, and that's the one that we're going to look at today. And it's just a really common data set because it has it's a small data set. I think it has 32 observations. Okay, and it has, you know, a good distribution of numerical variables and categorical variables, and some that are hard to classify, right? And so, so our first job once we have this data set, is to look at each of these variables, and maybe just from the description, we'll be able to classify whether these variables are numerical or categorical. Right? And so let's see here. Bring this whole kit and caboodle in here. Oh, maybe not. Crop top. Whee. And oops. I want to put this here. Crop this. Uh-oh. Move it down on this page. And I also want to include the description. Okay, so for categorical data, okay, and we'll get to it more, we should visualize using a bar graph. And I think I talked about it in the video, but we're going to talk about it again. But for now, let's just focus on identifying categorical and numerical variables. Okay. And so here, the MT cars data set, and it's spelled like this here, and it's a built-in data set in R. So if you just type in MT cars and hit enter or run that code, it'll bring up the whole data set. It'll just show you the whole data set. So we can just work with this data set right away. And that's really nice. Okay, and I'll show you what it looks like in a minute, because we sometimes might need to rely on the data, right, to kind of convince us one way or another whether it's numerical or categorical, right? But the MT cars data set is data that's extracted from the 1974 Motor Trend US magazine, and its focus is on fuel consumption, and 10 other aspects of cars, I guess. And so there's 32 observations on 11 variables. So already I know that we have 32 rows and 11 columns. Okay. So from here, right, I know I have a data set that looks like this, 1, 2, 3, all the way down to 32. And then I have variable 1, variable 2, all the way up to variable 11. Right? And what those variables are, right? Those variables are here, okay? And so this is basically a code book, right? It's kind of a simplified code book. And any data set that's built into R especially will have this kind of code book available. Okay? And so, and maybe I'll remember to show you, I'll try to remember to show you, it's not important, but it's kind of nice to have how to access this information. But first, let's talk about these variables. Okay, so there's a variable called MPG, miles per gallon. And because it's a measurement, and especially because I have units here, that's a dead giveaway that this is a numerical measurement. Okay. And so here, this is numerical, right? The miles per gallon. Okay. So what I want you to do is just kind of read through this list and try to decide for yourself which one you would classify as numerical or categorical, or maybe there's some that you have a hard time classifying, and then you would have to use that argument of, okay, well, it makes sense to talk about the average. Okay, so the number of cylinders. Now, one thing that I will mention is we're going to come across this a lot, right? Where we don't actually know, I don't know anything about cars, And so sometimes that's a disadvantage, but often it's not. It doesn't really matter. You could look at the data and just from some Googling, you could find out that there's only a certain number of cylinders that a car can have. Now, we could call that numerical and we could call it discrete, but that's not really the case, right? Because it doesn't really make sense to talk about the average number of cylinders. Oh, you should make a car with 5.5 cylinders. No, the only options are 4, 6, and 8, as far as I know, right? And so, and again, I don't know a lot about cars, but especially in 1974, right? 4, 6, and 8 cylinders were the options. And so then we would talk about how many of each of these cars there are. And so that would make it a categorical variable. Yeah. For the displacement, again, I don't know what displacement is, but I see that there are units here. And so that's a dead giveaway that this is a numerical measurement, right? As soon as I have some units, it's been measured, then it has to be numerical. Okay. Horsepower. So the gross horsepower is one of those things where I might be kind of on the fence, right? And then, so my go-to thought would be, okay, can I reasonably talk about the average horsepower? Yes, I can. To me, that makes sense, right? Maybe it's possible that to you that doesn't make sense. So then you would argue it's categorical, right? But this is kind of the first one where I'm going to say numerical because the average horsepower makes sense. Using some shorthand here. Okay, that would be my argument there. Get a little closer. Okay. DRAT, rear axle ratio. Again, I don't know what that is. The term ratio to me triggers a numerical, right? Because it has to be a number. Okay, so good question. Would you mind resending that to everyone instead of just to me? I'll wait for that. Awesome. Thank you. Okay, so there, now everyone can see it. So for the number of cylinders, wouldn't it depend on the situation? So for example, for cars, it would be categorical, but if we're in a factory or something like that, it could be considered numerical. But so now this is one of those instances where, yeah, I could probably be persuaded either way, but because this data is for specific cars, I'm going to go with categorical. But exactly, so it depends on the situation. And so everything is very fluid, and that's what makes it hard in the beginning, right? But it also makes it fun because it's kind of this song and dance of, okay, well, you have to know the rules, but once you do, you can argue anything, be dangerous. So yeah, so good thinking. It totally depends on the situation. Right? So for the rear axle ratio, I don't know what it is, but the term ratio to me makes me think numerical. Right? Might be numerical. In this case, right, I don't have any other clues because I don't know what the rear axle ratio is. And so what I'm going to do is I'm going to look at the data. right? So we can look at the data to decide. Okay. Okay, so the question was, the number of cylinders they're integers, right? 4, 6, 8, right? These are numbers, but this is going to happen a lot where we use numbers, right? But those numbers aren't always numerical. Okay, and so in this case, 4, 6, 8, those are categories. So someone is arguing, okay, well, the average number of cylinders makes sense to me. However, if you're trying to make recommendations, right? So imagine you're writing this report for your boss, and your boss says, okay, if I had to make this amazing fuel consumption car, right, with this really good fuel consumption, fuel economy, miles per gallon. So I want it to be high, right? Because I want high fuel economy. Then you can't tell your boss to make a car with 5.5 cylinders, for example, right? Even if that's the average for the best fuel consumption, that doesn't make sense, right? And so your boss would come back and say, well, I can only do 4, 6, or 8. So which one is it? Right? You'd say 6. Okay, great. Right. And so often we use numbers, and we'll even see that here later where it's more obvious, where we use numbers as placeholders for categories. Okay. And so don't be confused by that. Although in the beginning, everything's confusing, right? Okay, so let's have a look at the data. So I've pulled it up here in our studio. Oh, okay, let it wake up here. Your project went to sleep. Cute. Well, yeah, I mean, not really, because it's just the data set. Then we can make that argument about whatever data set we're talking about. So, right, but the goal is to talk about what kind of variables do we have. And this is going to happen a lot, right? So the comment was, this feels like a class on cars rather than statistics. But the first step when you get a data set is to learn about the data, right? And so one of those is to determine, do I have numerical variables? Do I have categorical variables? Because what that's going to do is it's going to determine what you should be doing next, right? How do I learn about these variables? So in this case, yeah, we do need to know something about cars, right? And you might have to look into it, right? Because we don't always know everything about our data, right? Okay, so I have this, and I'm not gonna, I'm gonna try to zoom in again. Okay. So this, because it's so brief, I'm not going to post this R code, but you can easily replicate it. And what I'm going to do is I'm going to use the head command in R. The head command yields the first 6 values, so that the head of the data, you can use the tail command for the tail of the data. But either way, it's just to get a glimpse of the data. Now, the head command of empty cars. So empty cars is the name of the data set. You could save it as something else and you could use that name. But in this case, I'm just going to use the empty cars, which is built in. So if I run this code, run this selected line here, then I get this output here. Okay, and so I'm going to save this and bring it in here. Insert. Okay, let's maybe make this a little, just a smidge smaller. Okay. So for the rear axle ratio, right, what we said was we can look at the data to decide. Okay. Now, so I'm going to look at this data. And so what I did was I used the head command, and the drat here. Let me see here. When I look at these values, these look like numerical measurements, right? It doesn't look like there are distinct categories here. It looks like typical measurements are between 3 and kind of 4, right? 3.9, 3.9, 3.85. So for this reason, I'm going to look at this data and I'm going to say it looks like it might be numerical, right? And so I'm going to stick with that. And so here, I'm going to say it looks numerical. Okay. The next variable that we have to decide is the weight. Okay. It's in thousands of pounds, but so again, kind of a giveaway that this is going to be a numerical variable, right? Because I have a unit, right? So here, this is going to be numerical. Okay. Cusec is the quarter mile time. So how long does it take to drive a quarter mile? I guess probably at top speed. And so again, we can kind of rely on the data, and it looks numerical to me, right? But also time has some unit, right, in seconds. And so I'm going to call this numerical. Okay. Now, this is the first, so the VS variable, which is cut off here, it kind of goes on. But the VS variable has this dictionary, right? So 0 indicates a V-shaped engine and 1 indicates a straight engine. So here it's more obvious that this would be a categorical variable despite having numerical entries. Okay, this is a special case where we call this a binary variable, 0, 1. Okay, and so the engine is indicated by this, and it's called an indicator variable or a dummy variable. 0 means it's V-shaped and 1 means it's straight. But because we have these categories, right, then of course it's categorical, despite having numbers in there. Okay? And we use that a lot. So that's why for the number of cylinders, it's not as obvious, right? But it does happen. So just kind of keep that in mind. Now for the transmission, we have the same thing, right? So it's either automatic or it's manual, and they've been coded as 0s or 1s. So again, binary data or indicator variables or dummy variables, if you've heard of those. It's just when we use 0s and 1s. So again, this is going to be categorical. Okay. Gear is one of those where I don't know, it doesn't make sense to talk about the average number of gears. Maybe, right? And so I could be convinced either way here. And same thing for the number of carburetors, right? And so here, I'm going to say I could be convinced either way. Okay. And so that can happen, right? But just remember your argument, right? We're not going to focus on those variables, so I'm going to ignore them for now. But if you were to incorporate them into your analysis, then of course you would have to decide how you're going to treat these because it's going to make a difference. Okay, they are numbers, right? But because the number of gears is limited to a certain number of values, right? Then you could argue that it's categorical. And what would your argument be? Because it doesn't make sense to talk about the average number of gears, right? And if you're kind of thinking, well, maybe it does, maybe you know something that I don't, right? Then you would say it's numerical, right? So I'll leave those for you to kind of think about, but we could also go back to the data set and just kind of have a look here, right? So for the gears and the carb, you would have to make a decision, right? So it looks like there's only limited values. Remember, this is only the first 6 data points, right? And so it doesn't tell us the whole story. And so first thing we have to do is identify, do I have a categorical variable or do I have a numerical variable? Okay. The next thing we want to do is we want to summarize. So once we have identified a categorical variable, once we have identified a categorical variable, we will want to summarize it using a table. So usually we use a table. We will want to summarize it. Oops. Using a table. Yeah. So I'm going to grab this little, oops, there. So if we look at the first categorical variable, oh, I see, page break, which is the cylinders, right? Then we can summarize the cylinder variable in a table. Okay, and it just shows the counts of the cars in each of the 3 categories. Okay, so if I use the table command, and here the data set is called empty cars data, and then the column name. And the $sign just says, go to the empty cars data set and pull out the cylinder and only consider the cylinder column, right? So it has to be the same name. And then if I wrap table around it as my function, then it gives me a table of those values. Now, if you have a numerical variable, often what's going to happen is you can make a table of numerical data, but then it would just be a huge table because there are very it's uncommon that you have the same number occurring more than 2 or 3 times, right, for numerical data. So you can make a table, but it's not going to be very useful for numerical data. Okay, so we have these categories here, 4, 6, and 8, and then the counts in each of them. Okay, and so this is one way that we can summarize this data. Now, usually we want to look at how do I visualize this, because our brains don't do a good job of comparing 11 to 7 to 14, right? We can pick up the highest, we can pick out the lowest, and then the differences between them might be lost, right? And so our brains don't do a good job of that. So then that we bring in we use visualizations to quickly learn about, or to quickly learn the information in the table. So it's just to get a quick idea of what's going on. So the visualizations that we're about to see are just the table, just visually instead. Okay, and so we've got this, we can make a pie chart or we can make a bar chart. And this is where I go on kind of a rant and say, okay, even if we didn't have these values, these exact values, the counts, 11, 7, and 14, if I just asked you to look at just the pie chart and tell me just quickly, as quickly as you can, which slice is the biggest, okay? If you let yourself take enough time, you will see that it's the 8 slice, right? But hopefully, you notice that it wasn't obvious. And that's because our brains do a really bad job of determining area, right? It's just our brains don't work that way. And so, so my goal is to have everyone say, okay, for categorical data, we'll use bar charts. Why? Because the differences in the heights of the bars is easier for our eyes to detect. And that's the whole goal, right, of visualizing data, is to have something that's easy to see and quick and concise to visualize. Okay, and so here in the pie chart, is it clear which slice is the largest, right? And so here I would say no. But then in the bar chart, is it clear which bar is the tallest? Yes, right? And so for that reason, and this is why we should only use bar charts for categorical data. Okay. So that's something to keep in mind, right? And so just in general, just avoid pie charts, they're bad. The only time that you might use a pie chart is if you have 2 categories, but let's talk about that and how silly that is in just a second here. Okay, so you might consider adding labels to the slices to help you kind of pick which one is which. You might add values, right? You might add percentages, you might add more information, but just remember, the goal is to have clear and concise visualizations, right? Without all the explanation that you might feel you have to put into it, okay? And so the only time a pie chart is obvious is when there are only 2 categories. But if there are only 2 categories, then knowing the count, right, of one gives you the count of the other. Or if we think about percentages, right, knowing the percentage of one, for example, if I tell you that the percentage of the class that will pass this course is 90%, your brain automatically goes, 10% of us are going to fail? Well, I just made that up, right? But our brain does a good job of splitting into 2. If there's only 2 outcomes, then we only need one number to figure out the other one, right? And so, right, so if there are only 2 categories, then knowing the count or the percentage in one category means that we know the count or the percentage in the other category. And so this is where I want you to look at that video and watch that video that I posted on Moodle, where it's where he goes half do or half don't, right? And so here, see half do or half don't. Oops. Video. Right, that's the same thing. Half do or half don't, well, both, right? And so we only need one to learn about the other. And so, and that would be more concise, right? Being able to just give one number instead of a whole graphic, right? So here, as an example, the percentage who agreed with a statement in the sample was 43%, which we know then that the other 57% disagreed with the statement. So usually we use tables to summarize categorical data, right? And so we can make frequency tables of the other two categorical variables. So the cylinders again, and then the V-shaped engine, which we said, okay, 0 means that it was a straight engine. Let me check. Yeah, sorry, V-shaped. So 0 means it's a V-shaped engine, and 1 means it's a straight engine. So you'd have to keep that straight when you're analyzing your data, right? And so in our data set, we had 18 V-shaped engines and 14 straight engines. Okay. Now, analyzing and looking at single categorical variables can only get us so far, right? We can get counts in each of the categories, and that's it. So usually what we're more interested in is how do these two categorical variables relate to one another? So it'll be a lot more interesting, and maybe I'll just try to grab. Can't remember where our page break is coming up. Haha, soon. Yep. So if we look at a contingency table, and a contingency table is a table that summarizes data for two categorical variables. So two categorical variables. Now, if I look at the cylinder and the VS, right, then I have the number of cylinders and the V-shaped engine as my two categorical variables. So notice in the table command, if I separate things with a comma, now let me just bring this down here. Okay, there. If I separate things with a comma, then it'll take the first argument as the rows, the row variable, and the second argument as the column. So depending on how you want it to be set up, then just remember that that's the order, right? Rows and then columns. So if you wanted to switch these, which is totally fine, then you'd have to switch the order there, right? But it still uses the table command, and all it does is it puts the counts. So there was one car in the data set that had a 4-cylinder engine and a V-shaped engine, right? And then there were 10 4-cylinder engines that had a straight engine, right? And so we can look at the distribution among the categories, right? So usually we're not really interested in raw counts because it's hard, again, it's hard for our brains to do something like 3 out of 32. right? It's hard for us to do that. So instead, we would look at the proportions, right? And so to consider the proportions, right? The proportions are basically percentages, right? And so, but in general, when reporting on categorical data, we should use proportions. So proportions are the number in a category over n. In this case, we have 32. We don't need to do it by divide by 32 explicitly. R has a prop.table command that'll just do it for us. Okay. So we should be using proportions instead of these raw counts. Okay, so what you're going to do is the prop.table command has to be applied to a table. Okay, and so that's just something to keep in mind. Must be applied to a table. Oops. Okay, so what I did was I had that table from earlier, and then I assigned it to something called sil versus tab, or sil vs tab. Can't remember what it was. The two names of the variables and then table. And then I took the prop.table command around the sil versus tab, sil vs tab. Okay, and then it returns these proportions. Now, one thing to remember, especially for chapter 3, is proportions are probabilities, which are roughly percentages. I say roughly because I have to multiply by 100 to get it to be a percentage, right? But they're all the same. So one thing I want you to notice and pay attention to is that all three of those P's mean the same thing. Okay, and so here, what's the probability of having an 8-cylinder car with a straight engine? Looks like 0. What's the probability of having an 8-cylinder car with a V-shaped engine? 43.75%. Right? Probabilities, percentages, proportions, they're all the same. Okay. So, good. To visualize categorical data where we have more than one categorical variable, we can do a couple of things. Okay, so we can incorporate both into one graph, and we actually have two options for it, two of the most common options. So I've shown you the code for doing it. Just as a note, right, the par MF row here, don't be scared off here. This just puts the graphs side by side. Puts the graphs side by side. Okay, so nothing crazy there. But what we're doing is we have the bar plot command. And so the two options that we have are a segmented bar chart, which is this one here, or a side-by-side bar chart. Now, a side-by-side bar chart puts each of the bars side by side, of course, and here, as opposed to this side by side, which means two graphs side by side. So it's a little bit different. Whereas here, each segment is part of the same bar. Okay, and so it shows how much of each bar is made up by each category, right? And so here we've summarized two pieces of information, the V-shaped engine versus the straight engine, and how many cylinders each of the cars have, right? And so, but we're showing the same information here in both of these, right? And so we've added a legend to the chart. I didn't spend any time fixing it because there's some overlap here. So I wouldn't publish this, but well, I guess I did, but you have to add a legend because otherwise we don't know what each of the different shadings mean. Okay. Okay. So these are the options, most basic options, and there's lots of other ones that we could use for visualizing two categorical variables. Now, the other option is, what if I have a numerical variable and I want to consider it across a categorical variable, so across some groups? Okay, so then what happens is we can look at side-by-side box plots is the easiest way to do that. Okay. So if we want to visualize the distribution of a numerical variable by a categorical variable, we can use a side-by-side box plot. And so what we can do is we can say, okay, this is my y variable tilde x variable. Okay, just to emphasize that this is a tilde here. And if I use a box plot, then it takes this command, y tilde x. You can do x comma y, but for later reasons, I want you to use y tilde x. Okay. And so the y should be the numerical variable, and the x should be the categorical variable, because I want to look at my numerical variable across groups. Okay. And so let's see here. What does it look like? Okay. So here, notice that I've got my numerical variable here on the y-axis and my categorical variable on the x-axis. So it breaks it up. It breaks up and makes separate box plots by the categories, right? And so this is how we would compare the miles per gallon for each of the cylinders, right? So now we can compare the box plots for each of the categories, right? And that tells us the miles per gallon for each of the categories. Of course, the 4-cylinder cars have the highest miles per gallon, and then it decreases. In fact, there seems to be no overlap between the 4-cylinder miles per gallon and the maximum of the 8-cylinder miles per gallon, right? And so that's one kind of key finding that we see right away. And you can compare these just to look at the differences in the miles per gallon. And so to end us off here, a little funny from How I Met Your Mother, where Marshall has made a pie chart of his favorite bars and a bar chart of his favorite pies. I will say it makes no sense because you can only have one favorite. But anyways, it's just funny. If you have any questions, let me know. Otherwise, I'll see you on Tuesday, and I'll post a video for tomorrow starting probability. All right. See ya. Stop this recording.